All right, so this is the probability section and basically some of the formula section that I wanted to talk about. You definitely need to know how to calculate outliers, and probably I should have talked about that in section 2. Please remember, if it's on the fence, it is not an outlier. But those are just the formulas that you use to create the fences for box plots. That's what the lower fence and the upper fence are. And then, and that's using the IQR method. So if they say the word IQR or interquartile range, they know that they're referring to this. Otherwise, you're looking for 2 or 3 standard deviations above the mean, and you can use 2 standard deviations above the mean and be fine with that. On the formula chart, they give you probability of A given B equals the intersection. Anytime they say given, you're going to be using this type of formula, and quite frankly, you may need to make a two-way table. And by the way, quick formulas and reference and hints, this came off the Weebly site. It's right on Mr. Spencer's formulas and definitions. Mutually exclusive. 2 events cannot occur at the same time. There's no overlap. Please do not forget that. Also, when you're talking about independence, you have a couple of ways to do it. The first way, if the intersection A and B, or and remember that's the intersection, equals A times B, then they are independent. Please note, another word for intersection is both. All right, so A and B, both A and B, or the intersection, that means they're talking about this part of the formula. And if that A times B equals that, they're independent. Less likely that you're going to be required to do independence in this way, but if A and B divided by B equals the probability, and this should say equals the probability of A, how nice to have the typo there, then they're independent. But that should be A, and I'll try to get that fixed. The general addition rule, this is also on the formula chart. Be very, very familiar with this, almost guaranteed to see it on a free response and on a multiple choice or both. So A union B, A or B, right? What's the probability of 2 things happening? Remember, the probability of 2 things happening is the probability of one of them happening plus the probability of the other one happening minus the intersection. Now, if they're mutually exclusive, this intersection is 0. But if they're not, you're going to have to subtract the overlap. And that's really important when you're working with the tables, that you make sure that you subtract the overlap. All right. A lot of times they'll give us a problem like this and ask for us to calculate the mean and standard deviation. And our immediate desire is to put it into L1 and L2, which is great. That is how you're going to calculate it, but you must show your work. If you don't show your work, you won't receive any credit for just giving the answer. And so basically for the mean, it's this times 2 times the 0.15, 4 times the 0.3, 6 times the 0.35, and then 8 times the 0.2. And how did I get that? This plus this had to equal 1. So 1 minus these 3 would give me that value of 0.2. The standard deviation is going to be the 2 minus whatever the mean was that we calculated here, squared, times 0.15, and do it again, and then do it again. Please remember, you can also just do the lowest and the highest and put plus dot 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 plus. The formulas for geometric are given on the formula chart. How do you recognize a geometric? I recognize a geometric by looking for the word first. All right. If it's the first, what's the probability of the first success? Or when, and if I say what's the probability of the first success, then I'm using the geometric PDF. On the other hand, if they're saying when do I expect the first, when do I expect it to occur? As soon as they use the word expect, we're talking means. So expect is a key word for means through all of probability. And so the mean of a geometric is 1 over P. And once again, this formula is on the formula chart. CDF, what's the probability the first occurs within multiple values? The first occurs within the first 3, or between 2 and 4, or whatever. Binomial. The phrase to look for is out of. All right. You have a fixed number of trials. We're doing it out of 6 attempts. What's the probability of something happening? And the probability must be consistent. Probability doesn't change, just like it doesn't change for geometric because of Bernoulli. PDF, it occurs on a specific value. CDF, it can be one of multiple values. Here, there's a list of keywords given. All right. To use the normal, you must have the standard deviation of the population. All right. They must give you the standard deviation of the population. And I'm usually going to be using this particular normal when they say, not only do I have the standard deviation of the population, I'm also working with the mean, and they're looking for what's the probability that one thing happens. All right. What is the probability that a person does this, or a vehicle does this, or a battery? It's a something. So the probability of one is when I'm using this. Normally speaking, if they're asking for the probability, all right, if they're asking for the probability, you're going to be working with a norm CDF. If they give you a probability, or they give you a percent or percentile, that's when you use the inverse norm. So if they give you the app, the area, the percent or the probability, it's an inverse norm. If they ask you for the area, the percent, or the probability, it's a norm CDF. Now there's a difference between this formula and this formula. Here, we're dealing with averages, all right? We're dealing with averages, but once again, we still have the standard deviation of the population. Well, how do I know if I'm dealing with average? Well, typically they will say that it was an average, but if they don't, you're going to see the word group, or you're going to have a sample of more than one. Now, I do not have to have a sample size of 30 to use this. I have to have the standard deviation of the population, and they need to tell me that it's normal. Okay, so two things. It needs to be normal. They need to tell me it's normal, and I have to have the standard deviation of the population. And I think there's a question here. So can we pause this, please? Can you pause this, or do I have to? I can pause it. The t distribution. All right, with the t distribution, it's almost exactly the same formula. The difference is we are working with the standard deviation of the sample. All right, so these are almost exactly the same, but this is working with S, the standard deviation of the sample. Now, there's some restrictions on when I can use the t distribution. If the underlying distribution is normal, and they tell me that, I'm good to go. If my sample size is 30 or larger, then I can do it as well. And then, of course, when we're doing hypothesis testing, if they don't do that, then I have to graph the data to check for normality. So the t distribution, the difference between the z and the t is here I'm using the standard deviation of the population, and here I'm using the standard deviation of the sample. All right. Okay, one of the questions is when do we use the t distribution for proportion questions? And the answer is never. All right, we will never use the t distribution for proportion questions. We will use it for z distributions, but never for proportions. If you think you're using a t distribution for proportions, it better be something they're talking about as in a regression equation, but it would never, ever, ever, ever be for test means. Okay, so proportions. All proportions are z-tests, every single one of them. That's good news. The question is, how do you recognize it? Typically speaking, they will tell you something, this out of that. But another way to know is there is no standard deviation given. All right. If there's no standard deviation given and you don't have a list of data, if you have a list of data, it's going to be a test for means or some other test. It's not going to be proportion. But if there's no data list and there's no standard deviation given, you're going to have to use a test for proportion. We've already talked about the z-test and t-test. Paired t-test versus a two-sample t. Two-sample t has two independent random samples, and you're going to look for two samples. That word, really important. We took two samples. Will let you know that, hey, it's a t-test. In a paired test, there's a natural pairing or matching going on. They match someone together. They have a before and after. They were tested twice. It was twins, but there's something what they were matching together, and they can match it one-to-one. They can actually say, hey, I compared one math teacher to another math teacher, one English teacher to another English teacher. That's fair, but they have to be matched one-to-one, and they're going to tell you that they're matched together if it's not the natural before and after. All right. But the word two independent random samples is independent is or two samples. They tell you two samples or two independent, probably a two sample t-test as opposed to a paired. That said, if they tell you two independent samples and they don't have a standard deviation, it's a two proportion test. All right. So once again, no standard deviation, proportional. All right, confidence intervals. Just real quickly, you can read this yourself. I'm not going to go over it, but this is extraordinarily important information. Sometimes it shows up in FRQs, and I can bet that it'll show up in the multiple choice. Very likely to show up in multiple choice. Someone put in the chat, and I'm not sure if this answers this question, but this is the way you determine sample size. All right, this is the way you determine sample size. And I like to take sample size by working the confidence interval formula backwards, okay? Otherwise, you get to memorize this, because basically this is the margin of error of a confidence interval. So all I'm missing is a p hat. All right, all I'm missing here is a p hat, and we can talk about that in a little bit. Power, absolutely need to know power. And that as sample size increases, power increases. And this is some miscellaneous stuff that you should probably read on your own. And I think that concludes that.